continuing on our journey here, I just want to work with this general term so much and get all of the ins and outs and understand everything that we need to do about this thing. And holy smokes, that's what the next like 10 podcasts are all about. Whew, let's go. Here we go. Look at this question. It says, one of the terms in the expansion. Now, watch out for expansions like this. The reason why is you know and I know. Go back a couple of podcasts and you'll find somewhere in there this term and this term somehow cancel out to give me no x's at all. And we call that a constant term, right? So in other words, the x's cancel out. We have x to the power of 0. Now in something like 6, which we have 7 terms, we could probably find that term out pretty darn simple. But here's the issue. What if that wasn't a 6? What if it was like this one down here, which is a 15, which we'll do in the next podcast. Okay, so let's see if we can figure this out just using our brains here. Well, first things first, I'm going to rearrange this. I know that this is x squared, but I'm going to write this other x as a -1 because you're going to find out that, remember, exponents on the denominator, when flipped, become a negative, but you're going to find out by putting a negative in there, it works out a lot easier. Okay? The second thing is I want to play around with this wonderful term here. I know a few things about this. I know the n because that was determined by the power right here. So I can actually put down that this is 6 choose, but I don't know the k. I don't know what term it is, and I don't know the k value. So okay, so I'm going to just put it down as k. Now, I'm going to choose my x. So my x, of course, is going to be x squared. Okay, so there's my x squared to the power of n minus k. Well, I know my n here is 6 minus k, which I still don't know. So the whole idea behind this is to find out what the k is. All right, times my y, which I know is, x to the -1, right, to the power of, guess what? K again. Ugh, my goodness. And that has to equal to some term, some kind of crazy term up here with an x to the power of 0. Right? So I'm right now, I don't care what this number is. I really don't. I want to look strictly at the powers and figure it out. Well, here we go. There's the powers. It's right there. So watch this. I know this is 2 times 6n minus k. So this is going to give me 2 times 6 minus k, right? This, because they're like bases, you know you got to add exponents. So I'm just dealing with the exponents. I'm going to add the exponents. This, of course, is going to be minus 1k, or just minus k. And that whole lot has to give me an exponent of 0. Oh, isn't that cool how that works out? So distribute. This is going to be 12 minus 2k minus k equals to 0. Combine like terms. This is 12 minus 3k equals to 0. Bring the 12 over to the other side. Oh my God, you look at this. K works out to be 4. Now look what we can do now that we know what k is. So check this out. This now becomes 6 choose. We know the k is 4. This is now x squared to the power of 6 minus k. 6 minus 4 is 2 times x to the power of -1, to the k, which is 4. And now we can solve this. We can find out what the number is in front of this x to the power of 0, which is the coefficient we're looking for. Well, if we do that and we do a couple of things here, it's actually pretty easy after that. Put this in your calculator. 6 choose 4 actually works out to be 15. X squared times 2 is x to the 4. Oh my goodness. -1 times 4 is x to the -4. And look at that. We get, in fact, the x to the 0 we were looking for. Right? This works out to be 15 x to the 0, or just plain old 15. Wow! Is that ever cool? So let's take this now one more step and look at something a little bit even more complicated. Let's look at this one. Same stuff, same thing. Don't get freaked out. It's exactly the same thing. So here we go. We know the formula. Let me just reiterate what the formula is. It's right here. As a matter of fact, I'll pick it up and drag it down there for us so that we can have it right at our ready. There you go. Okay, just like we did. We know the n is 15. Perfect. We know we have to change this. So this is going to be 2 to the x, right, minus 1 over x squared, which is x to the minus 2, right, okay, to the power of 15. That makes it so much simpler. We know the n value is, of course, 15, so this is going to be 15, choose whatever the k is, right? And if you read this question, we want the term independent of x. That's the same as saying x to the 0, folks. That's just too easy. Okay? So we got 15, choose k, right? Okay. Your x is going to be, of course, 2x to the power of n minus k. So this is going to be 15 minus k. Your y here is going to be minus x, right, to the minus 2 to the power of, yep, k. And you know that this is going to be some term to the x to the power of 0. See, it doesn't always have to be x to the power of 0. What if they said we want it to the term x to the 1? We want it to the term x to the 2. All you have to do is change this to whatever you need it to be. 1, 2, 4, whatever. Okay? So in this case, of course, it's going to be to the power of 0. So again, just look at the exponents. Here are the exponents. Right there. You know and I know then that this works out to be, okay, 15 minus k, right? 15 minus k plus a minus 2k all has to equal to 0. Okay? Put them together. You got 15 minus 3k equals to 0. Bring the 15 over to the other side. This is minus 3k equals to minus 15. So you find out that the k equals to 5. Oh my goodness. That is just so much fun now, isn't it? So let's go back. Now that we know that the k is 5, let's just go back to this original question here. I'll put the k equals to 5 over here to remind us. K equals to 5. So let's go. This will be 15, choose 5. This is 2x to the power of 15, 15 minus k, so this is to the 10. This is minus x to the minus 2 to the power of, guess what, 5, right? And that has to give us some sort of number up front here with a coefficient there of x to the power of 0. Great. Cool, cool, cool. Now, let's figure out 15 choose 5 then. Well, that should be interesting. Bring up the calculator. 15 alpha, boom, choose 5. Works out to be 3003. Holy moly. This is going to be 3003. 2 to the power of 10. I have no idea what 2 to the power of 10 is. Let's figure that out. 2 to the power of 10. Wow, 1,024. So this is going to be a big number. 1,024. Look at this. This is x to the 10. This, of course, is going to be to the power of 5. So guess what? That's still going to be negative, right? X to the power of negative 10. So look at that. The x to the 10 and x to the negative 10 cancel. Ha, 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 ha. Beautiful. And that should give us a really nice number. So what is that number going to be? Well, obviously, it's going to be a negative, and it's going to be 3003 times 1024. Okay, so let's work that out. 3003 times our 1024, and we get a value of, oh my goodness, 3075072. Okay, here we go. Minus 3075072. There's your beautiful answer. Holy smokes. What looked like a real tough question, if you follow the formula and you know what the formula is talking about, it's actually pretty straightforward.